Hello, my name's Roger Watson and this session is about the item characteristic curve. Here I've already drawn an x-axis along the bottom of the diagram horizontally and a y-axis vertically, and now I'm going to label them as they would be labelled in item response theory. On the x-axis we're going to represent the latent trait, and this is represented by the Greek symbol theta. Latent means hidden, so this can be any trait that we're measuring using a questionnaire with different items in it, and that latent trait may be something like depression or quality of life or anything that can be measured using a Likert type scale and subsequently analysed using item response theory. On the y-axis we're going to represent probability, and because this is probability, we know that probability can only run between 0 and 1. And this is the probability of obtaining a score on an item with a particular score on a latent trait. Item response theory essentially says that as the score on the latent trait increases, the score on an item will also increase. What I'm going to do next is I'm going to draw a curve, the item characteristic curve, that relates the latent trait score to the score on an individual item. But before I do that, I'm just going to mark another couple of points on this graph. I'm going to mark a point here in the middle of the range of the latent trait, which goes from 0 up to the maximum amount of the latent trait. And let's just assume, for the sake of argument, this is the mean score on the latent trait here, certainly the point of central tendency. So people scoring above that point are scoring high on the latent trait. And people scoring below this are scoring low. I'm going to draw it below the axis and you'll see why in a minute. So this range is low on the latent trait, this range is high, and this here is the mean. And here I've drawn, quite crudely, this is not great art, I admit, what's called an item characteristic curve. And the item characteristic curve increases monotonously, in other words it continually increases from the low end of the latent trait up to the high levels of the latent trait, and what it's doing is describing the probability of a score on any individual item in your questionnaire as the score on the latent trait increases, and that's what lies at the heart of item response theory. This property is called monotone homogeneity, whereby it continually increases. If, for example, the item response curve tailed off, as shown here in the dotted line, and decreased at some level of the latent trait, then that would be said to be violating monotone homogeneity, and that item would be removed from the analysis. And there are analytical techniques within Mochen scaling for detecting items which violate monotone homogeneity. So a good item should demonstrate what's seen here as monotone homogeneity constantly increasing over the whole range of the latent trait to indicate the probability of having a particular score on an item. And that's the basis of item response theory, which analyses the behaviour of these particular entities, the item characteristic curves, which are the unit of analysis in item response theory. Next I'm going to demonstrate how items can differ in their ability to discriminate levels of the latent trait. What I've drawn here in red is another item characteristic curve which also passes through the mean value of the latent trait here. But this is a less discriminating item because it's measuring a wider range of the latent trait. The item in black measures a very discrete region of the latent trait around the mean value. This one measures a much wider trait. And items like this not only are less discriminating, it doesn't mean to say that they're no good, but they are more likely, as you can see here, to intersect with other items measuring different regions of the latent trait. And if they do intersect, you've then got to make a decision about the quality of the items and decide which one to remove. Obviously, if items intersect, you cannot interpret the score on the latent trait in terms of a score on the item. Above this level here, the score could relate to any of the items from the latent trait measurement. A measurement here could be related to this item or that item, you can't tell. So the best items are those that don't intersect, and preferably items that are discriminating less wide regions of the latent trait. In other words, giving you a much more narrow range of the latent trait. So you know exactly where they sit. You know that this item sits right on the mean. For example, this item here starts increasing at low levels of the trait and starts tailing off at high levels of the trait. So those two item characteristic curves, the black one and the red one, demonstrate the phenomenon of discrimination in different types of item characteristic curve. So just to show that we've dealt with discrimination, and because I've used a red item characteristic curve to describe that, I've written discrimination here in red, so that when I come on to the next phenomenon, which is that of difficulty in item characteristic curves, you'll see the difference between the two types of phenomena that I'm trying to demonstrate. Here in green, I've drawn a different shape of item characteristic curve. This is exaggerated slightly, but note that it still shows monotone homogeneity because it increases monotonously or continuously over the whole range of the latent trait. But what this item characteristic curve here is demonstrating is an easy item. In other words, an item that is scored high by people on low levels of the latent trait. It begins to score high at low levels and continues up to the maximum level of the score on the item and the maximum level of the latent trait. So that particular item is demonstrating a difference in difficulty level between the different item characteristic curves, and that one there is described as being an easy item. So I've labelled that item here in green, easy. Next, what do you think a difficult item would look like? Well, you probably guessed that it would be the converse, and I've labelled that here in green. This item here is a difficult item because it can only begin to score high by people who are high in the latent trait. So I've demonstrated in red the different ways in which item characteristic curves can discriminate, and in green how they can be easy or difficult, and therefore demonstrate the phenomenon of difficulty. So finally, just to recap, item response theory is based on a relationship between the level of a latent trait and the score on the items that are used to measure that latent trait. And item response theory says that the higher the score on the latent trait, the higher the probability of scoring high on an item. The basic requirement of items is that they show monotone homogeneity, in other words, that they continually increase over the whole range of the latent trait. Items can either be low in discrimination or high in discrimination depending on the slope, and they can be easy or difficult depending on where they begin to score relative to people who are either high or low on the latent trait. That's all I want to cover in this session. Thank you very much for listening.